Hello, math friends. Today we're back here talking about solutions to equations. I always feel super smart when I'm talking solutions. Whenever you're finding solutions, it feels good, right? So today we're talking about how can you tell if a system is going to have no solutions, one solution, or an infinite number of solutions, and can you explain it using a graph? So if I look here at my two equations, I'm going to start because I'm more comfortable when I have it in the form of y equals mx plus b. So I'm going to get my y alone by dividing 2 on both sides. And then my equations will look the same. So I get y equals 4x divided by 2 is going to give me 2x plus 8 divided by 2 is going to give me 4. So my new equation is y equals 2x plus 4. And I'm going to do the same thing over here. I'm going to get rid of this 4. And by doing this, it just simplifies it a bit. I get 8x divided by 4 gives me 2x, and 16 divided by 4 gives me 4. Oh my, look at what I've just found. I have found that actually these two equations can be simplified to exactly the same equation. So if I think about that on a graph, what it means is that I'm going to have a y-intercept here of 4, right there. And then I'm going to rise to run 1. This is my 1 right here. And there's the graph of this line. And then I could do the same thing here if I graph this line. Oh, look at it. It's a y-intercept of 4. Rise 2, run 1. Oh my, look at that. It's going to be exactly the same line. When I do that and I get two equations that have exactly the same graph, it means that they have an infinite number of solutions because all of the points are the same. So an infinite number of solutions. Let's look at one that might be a little bit different. So what if I have two things that look like this? Now, right away, I have two different groups here. I have this group, this system, and then I have this system. But the thing I notice is that that number in front of my x is the same. And same thing over here, which means my slope is the same in these lines. So if I think about what it means when a line has the same slope, I can go to my y-intercept here of 6. And then I have a rise 3, run 1, slope of 3. Okay, so here's the equation of that line if I just roughly sketch it. And then if I go here, I have a y-intercept of 9. Change my color to make it easier. My y-intercept of 9, and again, rise 3. I'll have to add another line to my graph, maybe. Run 1. I can see that these two lines are going to be parallel because lines with the same slope are parallel lines. So that means there's going to be no solution. Now, once I know that about parallel lines, and we learned a long time ago that parallel lines have the same slope, so I know these two lines, same slope, they're going to be parallel lines as well. Therefore, this one also has no solution. So once I know that trick about parallel lines, I'm set. Let's look at one other type. I might have something that looks like this. And now I'm going to go ahead and graph this one. I don't have the same slope, so I know the lines aren't parallel. The equations are not exactly the same, so I know that I don't have an infinite number of solutions. So let's just see. Here I have a y-intercept of 3, and my slope is 2. So I'm going to rise 2, run 1, rise 2, run 1. I can put a couple of points on there, and then I could put another one down here. And here's my line. Oops, oh, I went a little crazy there. Let's just undo that. Let's try again. Not drawing that line. Okay. And then I can go here. Let's change up my color, and I could go y-intercept of 1, and then a slope of rise 4, run 1, rise 4, run 1. And here's my line here, and I really easily can see that I have one solution right here on my graph. So they didn't have the same slopes, they're not the same line. It gives me one solution. So that's how we can tell how many solutions there are to a system of equations. It's pretty sweet, these systems and solutions. I just think you sound so super smart when you do these. Awesome. Rock on.